let's look at flow and fractured rock. So I just essentially was just focusing on unconsolidated materials, alluvial materials, but also the same thing happens in bedrock, okay, in porous bedrock. So here we're looking at cross section of a fractured sandstone and siltstone. We've got, here's our bedrock with these fractures, vertical fractures, subhorizontal fractures. Got soil and weathered bedrock on top. This blue line denotes the water table, therefore flow is in general towards the right, although as you'll see, it takes kind of circuitous pathways, and all of that's discharging to the surface water. This fault zone essentially also creates a preferential pathway or a high permeability pathway. Okay, so let's take a look at this. So again, we've got the bedrock, vertical fractures. Some of them connect up to other fractures, but not all of them. Now, as a result of the discontinuous fractured pathways, groundwater is flowing in this kind of tortuous pattern. Okay. And it's flowing, you'll see, generally slower than in some of the more continuous fractures. And it makes its way down over and discharges to the surface water body. Okay. In contrast to that, let's see, we're getting that right. There are places where you have continuous open fractures for hundreds of feet. I mean, these are extremely fast pathways for groundwater flow. So whereas groundwater flow in unconsolidated materials might be on the order of 100 feet per year, these things are probably moving, probably 100 feet, possibly 100 feet per day. So that was the pathway. So now at the top here, we've got a source. I pause it a little bit. So here's our DNAPL source, right? Our non-aqueous phase liquid source. It's heavier than water. It makes its way beneath the water table and into the fractured network. Okay. Now take a look at just a zoom in of just a portion of the bedrock where you've got a couple of these globules. Okay, so this is a zoom in. So you've got this fracture, this fracture. Here are some globules of the liquid waste, right? It's kind of trapped in these fractures. On this side, this circle represents essentially like a package of water, if you will, right? And that's migrating in direction of flow. And at this point, the groundwater is clean, right? There's no contamination. However, it makes its way near the NAPL where there's now dissolved contaminant, and groundwater to the right of this or down gradient is now contaminated. Okay, so take a look at that a couple times. So again, here are our globules. It's dissolving into the groundwater. This package of water flows through it. It's now contaminated, right? So you have advection, you got dissolution. And now we have a case where essentially you have these globules of waste, liquid waste. Let me call it trichloroethylene, okay? TCE. So that's dissolving into the water immediately around it and in these fractures. So as a result, again, the sandstone is porous. So now we have higher constant and it's filled with water. So now we have dissolved constituents here. It's then going to diffuse into this rock matrix. So what happens? Imagine we've got a spill starting in 1960. This material starts dissolving into the rock matrix. And just by way of the fact that mass is migrating into the rock matrix, these ganglia are also shrinking. Okay. So this is an example of source of a contaminant and its fate and transport, or if you will, its transport and fate. So here we kind of summarize it up. We've got the source of DNAPL. Groundwater is flowing. It results in a groundwater plume. It's a diffuse plume because of the diffusion and because of the matrix diffusion, which I just showed. These plumes are discharging to the stream. As you can see, there's a separate plume here which commingles. And this is from maybe a source farther to the west, and it's just migrating along a particular bedding fraction. So there's a lot of stuff going on here, and when you go to a site and you try to figure it out, you're really doing a very interesting combination disciplines. You're dealing with geology, you're dealing with chemistry and hydraulics, and in some cases you'll do some numerical modeling. So for those of you who might find this interesting, it is kind of an exciting field.